All right. Well, thank you for joining us today. Hope everyone had a fantastic Earth Day yesterday and is enjoying their spring so far. Thank you for joining us for the Florida Invasive Species Council's Partnership Assistance and Communication Committee's annual or monthly SISMA webinar, or FISC-PAC. We're here to help support the SISMAs and invasive species management across the state, to help increase coordination and work across fence lines to help manage invasive species. So for today's presentation, we will be starting off with this brief introduction and then getting our feature presentation on the Inhabit tool from Dr. Catherine Jarnevich, and then getting some FISP and SISMA updates. So as we go through the presentation, ask you to please keep your microphones muted. If you have any questions, don't hesitate to put them in the chat. I'll keep an eye out and we'll address any questions at the end of the presentation. So I'm going to go ahead and stop sharing and introduce Dr. Jarnevich as she starts to take over control for the presentation. So Catherine has developed a research program to assist multiple agencies and groups with species distributions, focusing on invasive species. Her current research involves the application of habitat suitability models to answer different applied research and management questions for various species across a range of taxa and spatial scales. A major focus involves predicting current and potential distributions of invasive species and then delivering this information through a co-produced web tool to inform management actions. Thank you very much for making time for us, Dr. Jarnevich.
Great, thanks for inviting me to talk to you all today. So I'm going to talk about the Inhabit, or the invasive species habitat tool that we've been developing for the last few years. So what is Inhabit? So it's a desktop optimized application that provides mapped and tabular summaries of habitat suitability models for currently 259 terrestrial invasive plant species that have all been requested by a manager somewhere, including some people in Florida. And these species are modeled across the contiguous United States. And so the web tool is the product of a scientist-practitioner partnership. So it's been co-produced and is designed to facilitate management actions, including development of species watch lists and targeted searches for particular species. So there's a lot of great data out there on the web that provide information on where species are right now. So applications like EDD maps that kind of aggregate occurrence information and can provide some sort of idea of where things are on the landscape. And there's lots of different data sources for this type of information out there. And so that tells us where things are right now, but not necessarily where they might be in the future. So just to give you a little bit of background on Inhabit, I said it was kind of a co-produced tool. So the idea for Inhabit really came when my research group was sitting down and talking with the invasive species coordinators for the National Park Service about the needs of their invasive plant management teams that they have across the country, and the research that my group did. And we came up with this idea for this web tool to kind of provide information and about where things might be in the future. And so we started that in 2018, and the tools kind of developed over time. And one reason I put this timeline up here is you can see there's different versions of the web tool that have been released. And then we also have different partner meetings listed in there as well. And so we have kind of an end user group that anybody's welcome to participate in, where we have virtual meetings to talk about what additional features might be useful to integrate into the web tool, and also how we could even just change the user interface of the web tool and make it more useful for people. So what does it look like right now? Here's a couple screenshots, one of the map and one of the tabular summaries. So again, it currently includes habitat suitability model outputs for 259 manager selected terrestrial plants for the contiguous United States. Serving both these map and tabular summaries. And the tabular summaries are produced across species for management areas. And I'll explain this a little bit more later in the presentation, but it can help produce a ranked risk of summaries across species for a unit. And then these are also can be integrated with information on where we know species occur right now to provide that information of where are they now, where might they be in the future, to help make watch lists and other things. I just wanted to mention that Inhabit's also been incorporated in as part of this National Early Detection and Rapid Response Framework, kind of in the planning phase of that. Again, trying to help inform of what species to look for where. So how do we make these maps that we're serving within Inhabit? So as I mentioned earlier, there's lots of different information from different sources out there about where things are on the landscape right now. So we can use all of those existing data sources to get information on the occurrence of the species that we want to develop models for. We can associate those point locations with environmental characteristics at those locations from suites of predictor variables that we have as gridded information across the country. And then we can feed that information into different model algorithms to come up with these mathematical relationships between the environmental characteristics and where things are found to come up with maps that we produce. So a lot of the data, as I mentioned, that's out there says where species are. But in a lot of those data sets, there's also information on how much of that species has been found at a location. And really, when we think about invasive species, we don't necessarily care about just where something is found, but where it might become abundant and really have an impact on the landscape. And so if we can focus in on that kind of subset of locations where a species might become abundant and therefore problematic, then that can be another tool to focus the limited resources we have. And so the data in these databases can be pretty messy when it comes to information on abundance and cover. So I have this word cloud down at the bottom of the screen on the right that pulled information from fields in these different data sources that somehow relate to percent cover of plant species. So it could be an actual percent cover value, or it could be a range, so a bend value, so 25 to 50%, or it could be textual information, so single plant, scattered clumps, dominant cover. And so with this data, we couldn't really fit a true abundance model to predict how much of something is on the landscape, but we could categorize these into, so the species just is found there, so it occurs, or we could say it's abundant. So we took any category that we could map to saying it's greater than 5% cover on the landscape. And then we came up with another category that we call high abundance. That's where it's greater than 25% cover on the landscape. And so we could map all those different values from the word cloud into these different covers, and we could fit 3 different sets of models. One with where the species occurs, one where a species occurs with an abundance of 5% cover or greater, and one where a species occurs with high abundance, so percent cover of greater than 25% or more. And so I mentioned earlier that the number of species we had in the website was 259. There's not abundance data for all of those or enough of it to fit models for all of them. So we had abundance models for 217 species and high abundance for 189 species. So I said we relate that occurrence information, so where a species is found, to environmental characteristics. And so we came up with a suite of 53 predictors for the contiguous US. And these are at a resolution of 90 meters. And these include different classes of predictors. So thinking about solar radiation, how much sunlight does a location get? Atmospheric water, so thinking about precipitation and evapotranspiration type predictors, temperature, topography, the substrate, so what's the soil like, biotic interactions, disturbance, and then there's another category that we added kind of in a later version is landscape water, so where water occurs on the landscape. And especially we added these in through talking with refuge managers at Fish and Wildlife Refuges in the Western US, where they felt like we weren't doing a good job of capturing habitat for species within their refuges that tend to be pretty different from the rest of landscape around them. And so this is an example of where getting feedback from end users and people on the ground trying to use these helped us improve the models. But so we have 53 different predictors here. A lot of the climate ones we have for different seasons of the year that could be important. And so how do we go about fitting the models? So a lot of times when researchers fit models for a lot of species, they use kind of a one size fits all. Here's the set of predictors we're going to use. Here's the parameter values we're going to use in the models, and they just fit the models, and there you go. And we've taken a different approach where we really try to look at each model for each species. So we select predictors based on a species life form and their life history. So if you think about an invasive annual grass species in the Western US, the climate data and the seasonality that we might use for that is going to be very different from a vine species in Florida, like what might be important for those species. So we try to take that into account in selecting the predictors. And then when the model's finished running, we review the outputs, we look at kind of statistical evaluation metrics, we look at response curves, thinking about the eco-plausibility of those. Does it make sense for the particular species? Look at the mapped outputs. Does that make sense? And we revisit parameters for the different algorithms and drop algorithms as needed. So we've run 5 different algorithms, but all of those might not be included in the final product because one of them doesn't seem to be performing well. So how do we make the maps then? So we have these fit models. And one thing that we've thought about a lot about is extrapolation. So for example, a lot of species we've had requested to model from people in Florida maybe don't have a distribution in the rest of the US. So we're not kind of capturing those broader environmental gradients in the rest of the country. And so the way that different algorithms work is they extrapolate to those other values greater. So if you think about minimum temperature, the range of values for minimum temperature in the state of Florida is going to be a lot smaller than when we add in, the state of North Dakota, where it gets a lot colder. And so we can mask areas or highlight areas that have conditions that are outside the range of those environmental characteristics used to fit the model. And so that's what I'm showing here, with the red color on that map highlights locations that have environmental characteristics beyond that range. And maybe comparing Florida to the rest of the country isn't the best example, because if it's a species that's, a subtropical species, you probably wouldn't expect it to be able to live in North Dakota anyway. But if you think about other species that might be newer to the US and have only had the chance to establish in a really small area, maybe in the mid-Atlantic, we don't really know, are they going to be able to expand further south? Are they going to be able to expand further north? And so that's where kind of thinking about where we're extrapolating could be important. And so we create maps that both don't allow for extrapolation to occur and that do allow for that. And the way we do that is we take the maps from the different algorithms that we're going to include. For this particular example, I have BRT up at the top with an X through it because that model didn't look like it was doing well, so we removed that. And then kind of did an average across the other algorithms to come up with the maps that we use. So thinking about the maps that we made and iterating different models, thinking about extents and the predictors that we use. We've asked some questions along the way to kind of based on input from managers and what they were kind of skeptical of. So some of these are national models good enough? So if we fit models using data from across the nation, is that good enough, or do we really need regional models? Because you can think that there's regional differences in suitability for species. And so we did one study where we fit models for different regions within the country, and then one for the US. And what the graph is showing is if there's a point above the line, then the Inhabit model, kind of that national one, had better performance. And if there's a dot below the line, then the regional did better. And so in general, national models are good enough. Another question that we've asked is, do we need species-specific models? So selecting predictors for each species. And again, points above the line indicate that that is better than kind of a static set of predictors that you use for everything. Another thing that we thought about related to extents is what information do we want to consider when we fit models? So do US models work, or do we need to consider the entire globe? And so we did some analyses with some well-established species in the US that had kind of a timeline of invasion. So we could take records from different points in time along their invasion history and fit models for the globe, and then fit ones for the US. And we found that predictor quality matters. So if you think about the predictors that we have available for the US at a 90-meter resolution, that's very different than similar data that might be available for the globe. So if you think about soils data, we might expect that soils data limited to the contiguous US might be more accurate and more at a finer resolution than when we're thinking about soils data for the whole globe. And so that really made a difference. And so it seems like fitting models for the US using US predictor data with US occurrences seems to work well. So with all of that, we end up with the maps that we serve through the web tool. So I'm going to give a little bit of an overview of what the web tool looks like now. So you can select a species, so one of the 259 species that we've modeled. You can select the map type. So what's being shown here is a continuous map. So from low to high suitability. And then you can select from the model group. So as I mentioned earlier, we have models for occurrence, for abundance, for high abundance. You can choose which one of those you want to look at. And then you can also turn on or off whether or not you want to limit environmental extrapolation. And then we also have the ability, you could choose a management area and zoom to that. And then all of the map outputs are also available for download. So that's the continuous predictions. To get to another type of map where we've kind of binned the values into suitable, unsuitable, the way that's done is we have these continuous predictions from 0 to 1, and you can choose some value in between where you say everything below that is unsuitable, everything above that is suitable. And we have kind of 3 different rules that we've used to do that. So a more comprehensive one that's going to classify more of the landscape as being suitable, a balanced and a more targeted one that's going to really focus in on those higher areas of suitability. So we have these 3 different threshold rules that we can apply, and we can do that to the occurrence map, the abundance map, the high suitability map, and then we can come up with a single integrated map across those that shows where are those areas that are just suitable for high abundance, where are those areas that are just suitable for abundance or high abundance, or that are suitable at all. And so on the web tool, if you select the categorical map, that's what you see here. And then, oh, sorry, my spacer's off, but you can choose to look at a more comprehensive, balanced, or targeted version of that kind of integrated map. So for those tabular summaries that I mentioned earlier, that are kind of these summaries by area, what we're trying to, the information we're trying to provide here is how much of management area is in each suitability category for each species. So how much of a management area is suitable for high abundance? How much is suitable for abundance? How much is suitable for occurrence? Or how much of it isn't suitable? And we have these summaries by area for a lot of different management area types. Again, these have been requested by different people. So it includes a lot of different federal lands, military lands, state lands, counties and states. And then we have some things like ecoregions and watersheds. So within the web tool, there's a couple different tabs related to this. You can ask for summaries by species. So if you do this, you could select a species of interest. You could filter it by management area type. So counties here, I've selected just show me BLM management areas. And so what this is showing us is every single BLM management area and the summary information for the species model for Ventonata. And so it tells you how much of the unit is suitable for occurrence, how much is suitable for abundance, how much is suitable for high abundance. And then there's also information on where the species has been recorded. So has it been recorded within the management area? Has it been recorded within 50 miles of it, within 100 miles? How far is it to the nearest occurrence? We can take that same information, but instead of filtering by species, we could filter by a specific management area. So here, a management area has been selected, and so you have 259 rows, so one for each species, and you can get that same information. So how much of the unit is suitable for occurrence, abundance, high abundance, and then how far is it to nearest record. And so you could use this information to kind of prioritize different species for a management unit, thinking about what you might want to focus on. So what are some use cases for Inhabit? So one is thinking about local search for a specific species. So I have a couple examples here. One where we went and looked in Rocky Mountain National Park for orange hawkweed, which is a species of concern there. We looked in locations predicted as highly suitable and found a couple new locations for that species. We have another example from Joshua Tree National Park with fountain grass, where they looked at the model for suitability and went and looked in an area that they hadn't looked at for fountain grass and found some new locations that they hadn't been aware of. Another use case came from some people in Wyoming using our model outputs, and they used the Inhabit suitability by county for a few species as a like here's how bad it could get. So how much of this county is suitable for a species. So that's kind of the maximum number of acres that you might expect for a species to be established there. And then from county weed managers, they got estimates of how much of that county was already invaded by that species. And so they could compare those to get an idea of how bad it could get and come up with different scenarios related to cost analysis for control. Maybe one of the most common use cases is for development of watch lists. So using those tabular summaries to determine what priority invasive plant species that do not occur locally in a management area have suitability there, what invasive plant species that do not currently occur in a management area are at the doorsteps or nearby to those areas, or what species of concern pose a risk of secondary spread into an unyet invaded region. So maybe it's a species found in a nearby state that's not yet found within your state or a county or something like that. So these are just maps kind of counting the number of species for with suitability with these different filters. So how many species have suitability? We have occurrence, a column for occurrence and a column for abundance, a column for high abundance. And so kind of looking left to right, you can see that when you move from thinking about where something might just occur to where it might have high abundance, the number of species you might need to consider decreases. And then we also have different ways of filtering top to bottom. So thinking about, this is just the number of species with suitability. The next row here is just of those species with suitability, how many of them haven't been recorded within this, here it's watershed. And then the next level is how many species that have suitability haven't been recorded within that watershed, but have been recorded within 100 miles. And so again, that's the count of species. And then down below is how many species have suitability but haven't been recorded in that kind of larger watershed.
245.
And then under each of these is, you would be able to get a species list of what species had suitability there. And so this is just looking at the number of species from those different maps. And just getting across the point again that when you look at occurrence versus abundance versus high abundance, that you get a smaller number of species on lists. And the same thing can be said as we do this filtering from how many species are suitable, how many are suitable but haven't been found there yet, and then how many are suitable, haven't been found there yet, but are nearby, or how many are suitable but haven't been found in this entire region. So maybe we really want to keep it out. And so within the web tool, there's some filtering already available, but there's more coming soon. So this idea of invaders at the doorstep, say, select a management area. Here I selected the county that I live in, and I say, show me species that have suitability but haven't been found within 100 miles. And so that gets us down to 27 species from the initial list of 259 that we have models for. There's also additional management areas that we've been asked to add to the web tool. So that's something that we'll be doing in the near future. So if there's any other additions anybody's interested in, we'd be happy to hear those. And then there's a few future directions that I was just going to mention related to Inhabit. And again, these kind of future directions come from feedback from end users and things that they would like to see. So we've had a lot of species requested by managers that aren't yet established or well established in the US, but they are of concern. And so these newly established species, often there's not enough location data yet within the US to fit a model. And so we've developed a suite of global predictors at 1 kilometer And we have models for about 50 species now that we're going through the review process with USGS, and we'll have those out soon. And so those will be available within the web tool as well. Another project that we're working on in partnership with people with USGS, with the Non-Indigenous Aquatic Species Database out of Gainesville. And with this effort, we have fit models for 53 aquatic plant species using predictors that are for river or lake environments. And with this, we're also considering alternative potential futures. And right now we're getting ready to go through the review process with those models as well. And those will be out hopefully in the near future. And with that aquatics project, another thing that we've been thinking about is we have the suitability, so where things could establish, but also thinking about pathways and how they could get, how a species might be able to get from where it's already found to a new location. And so kind of coming up with this integrated risk score across pathways, suitability now, and suitability in the future. And so that's something we may be thinking about more for future iterations of Inhabit as well. So yeah, those are the kind of 3 big future directions that we have been working on. And we're always interested in what else other people might be interested in seeing and any suggestions to improve the web tool. And so I've included here a QR code. I think that should take you to sign up for the a newsletter related to Inhabit, where you can get information on when the web tool is updated, and also information on future partner virtual meetings to provide feedback on the web tool. And yeah, with that, I'd be happy to take any questions.
Thank you very much, Catherine. We don't have any questions in the chat yet. The one I had was like, how do we find out more information to join these user group meetings and provide some feedback? And you've already answered that one. Does anyone in the group have questions at the moment? I'm really excited to hear about the aquatic tool and how that's being applied there. I know invasive aquatic plants are very important here in Florida. We have a lot of really fantastic waterways and water bodies here. So making sure that we maintain those as healthy ecosystems is very important in our state. I guess my one other question is like the next updates. I see that you've done them close to about annually, like within December. Would that, if we were to suggest, like off the top of my head, there might be a few species, or we have our version of PRISMs, our CISMAs, Cooperative Invasive Species Management Areas. So getting those areas included as some of the projects or whatever you call them that people can search by automatically would be beneficial. Mm-hmm. So if we submitted that now, that might be something we could see, by the end of the year, maybe.
Yeah, definitely. And especially because we're doing an update just on those management area summaries right now. So that'd be a great time if you have a spatial layer of SISMA boundaries, we could definitely add that.
Yeah, I've got one of those and I'll get the email to you shortly.
Great.
I'm not seeing any other questions. I think you did a great job of explaining a pretty complicated process there. So thank you very much for making time for us. I think it's a fantastic tool that could be very beneficial for us. We, a lot of our SISMAs are focusing on our EDRR lists at the moment. So having this additional resource, I think is very useful. So
great, thank you.
Thank you. Give me a second to go ahead and get my screen back up, and I'll switch over to our SISMA update. Can you guys see everything okay? I'll take that as a yes. So we have a lot of great things going on across the state at the moment. This weekend, we've got 2 different fishing derbies. Just had another one that ended up this past weekend. So if you're down in the South Florida area at all, I encourage you to check out those events. Lots of planning meetings going on within our SISMAs, as well as some training opportunities. Another event down in South Florida, you got the Southwest Florida SISMA's Invasive Species Symposium. Continuing on, looking a little bit more at May, we've got some hardcore weed warriors that are still out there doing work days, even though we're really starting to get hot already. It feels like summer in good parts of the state. So you've got work days down with Treasure Coast SISMA for both invasive plants and invasive animals. Some more SISMA meetings. North Central Florida SISMA's got a work day. And we're looking at also a SISMA meeting later on in May. As far as announcements at the moment, don't really have a whole lot. If you aren't already aware, FWC is in the middle of their Upland Invasive Plant Working Group planning process right now. It's a great resource. I think for at least some of the working groups, there's still time maybe to get your proposals in, but you can look up that detailed information. We have a link that is available on the Florida Invasives website on the SISMA resources tab. Also want to make people aware of a job posting, the invasive plant tiered training program. We have a new position up for a content editor to help us create the training courses and get them online in the Canvas format. Looking at the rest of our SISMA calls for this year, next month we'll be learning about the invasive snake lungworm parasite. And then we have several other really good topics scattered throughout the rest of the year, 4th Wednesday of every month. So our monthly calls, this is recorded and we'll get it up on our YouTube channel fairly soon, in the next day or so. But you can view all the past recordings there and you reach out to me if you have any questions. And unless there's any other comments or questions from the chat, we're ending a little early today. So I hope all your meetings this week end early and that you have a great rest of your spring. Thank you for joining us.